guys, welcome back to my YouTube channel. So today we are going to solve day 29 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Today we are going to solve problem number 2684, maximum number of moves in a grid. Okay, so you are given a 0 indexed m into n matrix grid consisting of positive integers. You can start at any cell in the first column of the matrix. Okay, so you can start at any cell in the first column of the matrix and traverse the grid in the following way. From a cell, row, column, okay, so let's say this is a cell, okay, you can move to any of the cells, row -1, previous row and next column, okay, previous row, next column simply means that in this direction. Same row, same column is column +1, okay, this means that this direction, row, same row and next column, next row and next column simply means that this direction, okay, such that the value of the cell you move to should be strictly bigger than the value of the current cell. Okay, so here if value is 8, then if you want to move to this side, then definitely this cell should have value greater than 8. Okay, let's say 9. If you want to move from 8 to this one, so this cell should have value greater than 8, so let's say 10 here. If you want to move to this cell, then this cell should have value greater than this 8. Okay, 9, let's say. Okay, if the value is same or less than this, okay, let's say 7, 6, okay, something like that, then we can't move. Okay, we have to return the maximum number of moves that you can perform. Okay, so now let's see this example. Okay, so we can start at any cell in the first column of the matrix. Let's say I want to start from here. Okay, so I have options, this option, this option and this option. So I can move anywhere, right? Here I can't move. Okay, this is one boundary condition, I can't move, there is nothing here. 2 to 4 I can move, 2 to 4 I can move. Okay, let's say I move here. Okay, if I move here, then again I have three options, this and this direction. Okay, so 3 is smaller than 4, I can't move to this direction, so I'm going to move to this direction. Okay, this is the only option that I have. From here I have three options, this and this. I can't move to this cell because value is smaller. I can't move to this cell because value is smaller. I can move to this one. Okay, then from here I can't move in any direction. Okay, I have to stop. So how many moves that I'm taking? So this is first move. Okay, this is first move, this is second move and this is third move. Okay, total 3 moves. Okay, 0 to 0, 0 1, 0 1 to 1 2 and 1 to 2 3. Okay, 3 moves. Okay, same way here, from here you can move to this direction. Okay, one move, and from 4 you can move to 9. Okay, this is the only option that we have. From 9 you can move to this one. Okay, so this is also one option. So here also you see total 3 moves. Okay, from 5, okay, if I want to start from here, 5 4 4, there is no option, right? I can't move anywhere. Okay, so this is not a good path. Okay, from 3 I can move to this, I can move to this, I can move to this. Okay, all these are options, right? So from 3 I can move to any place, right? 3 to 4, 4 is greater than 3, 4 is greater than 3, 9 is greater than 3. Okay, so here if I move to this 4, then again this path 3 4 9 11, this is a valid path. 3 4 9 and 11, this is a valid path. 3 4 13 15, this is also one valid path. Okay, but this is a max value, right? We are getting every time. Okay, from 10 I can move to this, no, I can't move to this one, I can't move here. Okay, so what is the max value that we are going to get is 3. Okay, so this is what we need to do. Okay, so now see this example. 3, I have these 3 options, but I can't move anywhere. Okay, from here, that's what I want to start. I can't move anywhere. Okay, from here if I want to start, I can't move anywhere. So starting from any cell in the first column, we can't perform any moves, right? So I hope that you guys are clear, and these are the constant size. Okay, number of rows, number of columns. Let's write the code. So same thing we have to do, nothing much. Okay, simple problem. So here first let's calculate the number of rows we have. So grid dot length, and n is equal to pick first row and calculate the length. Okay, it is going to give me the length of the column. Okay, number of columns that we have. Okay, then we have always going to start from first column only. So here single loop will work. Okay, I is less than m, I plus plus, and here inside this what we have to do, we have to call one helper method. Okay, so here let's do one thing here inside this int, create one variable val. Okay, in this val call one helper method. Okay, and in the helper method what I'm going to do, I'm going to pass my grid, I'm going to pass my I value, and j is going to be 0. Okay, because we are always going to start from the first column. Okay, and m is nothing but the number of rows, n is going to be nothing but number of columns. And then here let's use memoization. Okay, side by side. Okay, so I am passing this memoization array. Okay, so let's create that. So here int max value we have to return, so create one variable. Okay, and then after that create one 2D memo array. Okay, and here new integer, and here you can write m and n. Okay, and here this is done. We are going to get one value here, and then we will just compare it with the maxwell. Okay, so maxwell is going to be math.max of my maxwell and the value that I have. Okay, so we already did the max value, right? And once this is done, we are going to return max val. Okay, so this is done. Right now let's write the helper method. So here, go here and write private int helper, and here we have to pass grid. Okay, this problem is actually very easy. I'm not going to say that this is on video level, very easy. Okay, we have to just do the same thing that I've explained in the story, right? Int j and m, int n. Okay, I'm passing all these variables. Okay, these parameters in the helper method, and here memoization array. So let me just copy this directly. Okay, now let's write a few boundary conditions. Okay, so if my I is less than 0, then we have to what we need to do all that stuff. Okay, boundary conditions. If I is less than 0, or I is greater than equal to m. Okay, or j is less than 0, or j is greater than equal to n. Okay, in that case simply return 0, because these are the boundary conditions, right? And there is no cell available at that positions, right? So this is done, and after that we have to check if this cell's result is already computed, then we have to return it from memoization array. Okay, that's a simple use of memoization. Okay, so here if memo of I of j, okay, if it is not equal to null, okay, then definitely means that we have filled that value somewhere. Okay, so initially it is null. Okay, I have initialized it here and it is null initially, right? So if we have calculated this, then definitely means that it is not null at that time. So we have to simply return memoization, okay, the value that we have stored here. Okay, this is done, right? And now the same things that we have to write. Okay, three directions we are moving, right? So we have to write the same story here. We are going to call recursion. Okay, so int max moves is equal to 0. Okay, and current cell, let's take current cell is equal to grid of I and j. Okay, now same thing, recursive calls for each direction. Okay, so here if my I is greater than 0, okay, and j plus 1 is less than n, okay, and grid of I j. Okay, so here I am moving to this direction. Okay, so above direction, right? So I minus 1, j plus 1. Okay, so here let's write like this, I minus 1 and j plus 1. Okay, so here what I'm checking, I can only move to the next direction if this grid of I minus 1 j plus 1 value is greater than the current cell. right? These are the things that we need to check, right, every time. So that is why I'm checking this condition beforehand. Okay, if I minus 1 I'm doing, so I should be greater than 0, so that I don't go to this boundary condition, right? And j plus 1 I'm doing, right? So j plus 1 should be less than n. Okay, clear? All right, now here inside this we have to update my max moves. Okay, max moves is equal to math.max of, okay, and here max moves we have to pass, and here now we are moving to the next section. Okay, so from this cell I am moving to this cell. Okay, so here 1 plus call the helper method for this cell. Okay, this is a simple thing that we have to do. 1 plus, and here call the helper method. So I'm just going to copy this. Okay, paste it here, and here grid I am moving to I minus 1, and I am moving to j plus 1. Okay, j plus 1, and here m n going to remain same every time. Okay, this is done. So this is what direction? This is nothing but upwards, right? Upwards to the right. Okay, so this is the direction, right? Upwards to the right. Okay, now let's write the code for this one. So here just copy this here, paste it here. Okay, and here I have to move to which direction? I have to move to the next row and next column. So here row is going to be same. Okay, row is going to be same. Now this time I am going to this direction, right? Row is going to same, column is incrementing. Okay, so here I have to write something like this. Okay, this row is going to remain same and column is going to be incremented. Okay, so here and same way I have to update this. So here I don't need this. Okay, because I'm in the same row. Okay, and here instead of this I have to write I, and here j plus 1 only. That's it. So here I have to write to the next cell in the same row. Okay, and now again copy this, paste it here. Okay, now here I have to move to the next row. So I plus 1 should be less than m, and j plus 1 should be less than n, and here I plus 1. Okay, and here I plus 1, right? So here I am moving from here to here, right? So I plus 1 next row and next column, right? So this is what I need to do here. Okay, now we calculate some results, so we have to store that result in the memoization as well. Okay, so here what I'm going to do here, we are going to store the result in memoization. Okay, so here max moves. Okay, this is done, and here from here return max moves. That's it. So simple, right? Now let's run it and see if there are any code issues. So the test cases has been accepted. Now let's submit it. So see, our solution is accepted and it beats 100% of users with Java, right? And the time complexity for this problem is going to be m into n, right? So we are starting from each cell. Okay, and then we are checking the possibilities. Okay, from here also I'm starting this, and we are checking the different possibilities. Okay, so that is why overall time complexity that I'm going to say is going to be m into n. Okay, so here m, and inside this we are calling helper method, and then inside the helper method we are checking different possibilities. Okay, 3 directions we have. Okay, but we are only moving to one cell every time, right? If this path I follow, then here, okay, here, then here. Okay, we are moving towards the right every time. Okay, and checking the possibilities. So I hope that you guys are able to understand today's problem. If you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.